Okay, 8.1, interpret quadratic relations. So a quadratic relation can be represented by a graph or by an equation in this form, okay? Y equals ax squared plus bx plus c. One of the major things that we're looking for here is that it has an x squared in it, okay? So the equation or the graph of a quadratic relation can be used to solve problems. So example 1, the path of a ball that was thrown in the air is modeled by this graph. Okay, what do the x and y values represent in this scenario? Okay, so the x value represents the horizontal distance. In meters. Okay, and the y value represents the height in meters. What is the maximum height the ball reached? So what we're doing is we're looking for the vertex, which there's a point here anyways already identified. So, okay, the max height would be 9 meters. And a lot of times these questions will say like, well, when does this occur, right? So what this is looking for is that like we have to connect that 10, 9. These two numbers occur at the same time. The horizontal distance of 10 occurs right when the height is 9. Okay, so the question is, how far had the ball traveled horizontally to reach this height, the height that we already talked about? So we can say 10 meters. Now, D, what horizontal distance did the ball travel before it hit, I'm gonna say a maximum. Sorry, this is the ground. Okay, so before it hit the ground, so it started at a horizontal distance of 0, and it went all the way to, that's between 20 and 22, so that's 21 meters. Okay. From what height is the ball thrown from? So this is actually asking for the y-intercept. So right here, the ball is thrown from 1.5 meters high. F, what is the height of the ball after traveling a horizontal distance of 6 meters? So we have to locate where is the horizontal distance of 6 meters. Well, that's here. So then what we do is we draw a line up until we reach the graph, and then we align that with the height. So the height is about 7.8 meters. Okay, and the same thing for G. What is the horizontal distance when the ball is at a height of 4 meters? So we go to the height of 4 meters, and we draw a line over to the graph, and we get a horizontal distance of 2 meters. However, we're not actually done because it hits the height of 4 twice. So keep going. When did we hit the graph again? Well, at 18 meters. Okay, and that's how we read a graph. Okay, example 2. The quadratic relation, and then it gives us an equation here. H equals negative 5t squared plus 210. And remember, this is our t squared. That's what we're looking for. Okay, describes the path of a rock that falls from the top of a cliff, with h representing the height in meters and t representing the time in seconds. Okay, from what height was the rock dropped? So this is like when time is 0. Okay, so if we take the equation and we sub in 0 for time, because that's right when it's dropped, okay, this entire term goes to 0, and we're left with 210 meters. Okay, so the rock was dropped from 210 meters. Now, find the height of the rock after 1 second. So, again, same idea, but we're subbing in the 1 this time. Here. So, negative 5 times 1 times 1 is -5. Bring down the 210, and we get 205. Okay, so at 1 second, the height of the rock is 205. Now, find the height of the rock after 4 seconds. Same idea. Okay, so this time we're subbing in the 4. So we're going to go -5 times 4 times 4 plus 210. Okay, and if you put this entire expression into our calculators, we're going to get 130 meters. Okay, now D is a little bit different of a question. It says, is the rock still in the air after 7 seconds? So here's the thing. If we sub in 7, so 7 squared is 49 times -5. So -5 times 7 squared plus 210. We get the answer of -35 meters. Okay? When we think about -30, like negative of a number, in terms of height, we're thinking that it went through the ground, okay? So we can conclude, therefore, the rock hit the ground. Because we can't have these negative numbers. The lowest number that we can have for the height of the ball is 0, which is the ground. Okay, now E asks us to sketch a graph for 0, 2, 4, and 6. Okay, so for 0, we already solved for that. It's 210. And for 4, we already solved 130. Okay, so for 2, we can go ahead and put -5, 2 squared plus 210. And for 6, it's going to be the same thing, -5, 6 squared plus 210. Okay, so this one we get 30, and this one we get 190. Now, going over to the graph, I'm going to put the x-axis. Well, it's not the x-axis in this case, it's the t-axis and the h-axis, right? Because going back up to the equation has t and h in it. So I'm going to go by ones. So 1, 2, 3, 4, 5, 6. And then up this axis, I'm going to go by 30s. So 30, 60, 90, 120, 150, 180, 210. And I'm going to graph it in red. So 0, 210, that's when it's dropped. 2, 190. 4, 130. And then 6, 30. Okay, and over here, it does not go through with an arrow. It would essentially like lie on the ground at that point. Okay, and we can label our graph h equals -5 t squared plus 210.